Hello everyone, I am Dr. Rohit Solanki. Today we are going to start our chain of videos on MRI physics. I don't know why people used to call it as tough or boring topic. We will try to make it as simple as possible and also as interesting as possible. So here we are with MRI physics. MRI physics. So why physics is tough, or like we always used to heard that like why we have to read the physics or know the physics. So now it's very simple for us to read the MRI physics. So we have divided the MRI physics into the four subtypes or four subcategories. First one, we will read about the basic and foundation of MRI physics, where we are going to learn about the introduction, basic physics and MRI machine components. Then we will learn about the core MRI physics, where we will discuss about the spin and precision, pulse sequences, K-space and image formation. Then we will go to the application and advanced. So here artifact, advanced techniques and safety in MRI, and then later on we will discuss the clinical applications like neuro, MSK and body imaging in MRI physics. So here for first class is on a basic principle of MRI. So basic principle of MRI, we have divided into the four basic steps. First one is the placing the patient into the magnet. So we can see that this thin patient is lying on the tray of the MRI machine. So first job is to just place the patient in the magnet. Second is sending radio frequency pulse by coil. Now there are multiple coils in the MRI machine. Later we'll discuss the types of the coils and all. So with the help of coils, we will send the radio frequency in the form of the magnetic field to the patient. And next, the patient will give us some signal in the form of the magnetic field. We will receive that signal or the extra energy given by the patient in the form of the MRI signal. And then we will transform this signal into the image by our computer Fourier's technology. So we have to do only four work. First, put the patient in the machine or the magnet. Second, send the RF pulse to the patient. Then receive the signal from the patient, and then the received signals have to be transformed in the form of the image to read out on the computer. So we will discuss one step by step. So this is the body of the human. Here we can see that there are multiple protons are randomly moving here and there. So why only we used to choose the proton? Because there is evidence of the water in our body, and water has two H plus molecule and one O2. So H plus is in evidence in our body. So we choose the protons. So protons are randomly moving here and there, here and there. We know that protons randomly moving in our body, and moving charge always used to create the current around it, and moving current or the charge will produce some magnetic effect around it. So simply we can say that this moving proton is creating some magnetic field around it, means the human body is creating itself magnetic field. So the question is, the moving charge will create the current. So this is moving charge which is creating the current, and this moving current will create the magnetic field. So you will ask me, if the human body has its magnetic effect, then why not all humans are attracted toward each other like this couple? So because in the vector form the charges cancel out the effect of each other. Like here we can see that this proton has a charge toward this side, another proton this side. So one another proton will be put their charge this side. So these charges will nullify the effect of each other in the normal position or in the random movement of the protons. But what happen when we put this patient into a magnet machine? So normally we see that the protons rotate on the spin movement. Like this proton will rotate around one axis on the axis called as spin movement. This is called the magnetic dipole moment. But when we align along the external magnetic field, then this proton will move into two different type of the movements. First is spin, in which the rotation of the proton around its own axis, while the precision, where the axis of the rotation moves forming a cone. Here we can see that this is axis and proton is moving along the axis called as rotation of proton around its own axis called as spin moment, while when the proton is moving and forming one cone, it is called as precision movement. So these two kind of movements will happen when we will turn on or put the patient in the external magnetic field. In the normal position, proton only rotate on on axis called as the spin movement. But after placing the patient in the magnetic field or the person in the magnetic field, now this proton will show the two type of the movement. First is spin movement, it means that proton will rotate around its own axis. Second will be the precision movement, where the proton will move along the axis with axis, like making a cone. So, what will be the frequency of the resonance or the motion of this proton? It depends on the how stronger the external magnetic field you are applying. So, this is coming out with the help of the Larmor's equation. So, what Larmor's equation said that the precision frequency of any proton depends on the external magnetic field, and one constant is there called as gyromagnetic ratio. So far we have discussed that human body has so many protons. The protons are randomly moving here and there and nullifying the magnetic effect of each other. And when we put this patient or the person in the magnetic field, this spin movement of a proton will get one more movement called as the precision movement, which form the cone. So this what is a longitudinal magnetization? Longitudinal magnetization, when the normal person is there, then proton will move in the random position. But as soon as we put this patient in our magnetic board or the magnetic machine, there will be a perpendicular or the longitudinal magnetic field will be there on the patient. This magnetic external magnetic field will align all the random moving this proton into one parallel line. So these parallel lines will be there of the protons. So all the protons will align themselves in a longitudinal axis. So if this is the z axis, then all the proton in will be aligned themselves along the z axis if the position of the patient is in the z axis. Example, these are the herd of a sheep which are moving randomly here and there. But as soon as we will turn on the magnetic field or put the patient in the magnetic field, all the protons, all the sheep will start to move in a parallel lines. This is called as or longitudinal magnetization. Either this shift will start to move in the same direction as the extramagnetic field. We will call it as a parallel arrangement. If some shift will go just opposite to the external magnetic field, this is called as anti-parallel movement. Ultimately, all the protons will be move in the direction of the external magnetic field. It is called as longitudinal magnetization. I am repeating it. Longitudinal magnetization is alignment of all the protons of the body in the direction of the external magnetic field. So, if this is the z-axis, this is the y-axis, and this is the x-axis, first we have to know that all three axes are perpendicular to each other. So, as soon as we will put the external magnetic field, all the protons either will go in the positive z-axis or the negative z-axis. This positive z-axis is called as parallel, and this negative one is called as anti-parallel. Ultimately, if we will make the vector, then all the negative will cancel the positive, and ultimately more positive will be there, and net effect will be in the positive z-axis. The forces of proton on the positive and the negative sides cancels each other, and thus there is always more spinning on the positive side or the parallel z-axis. So this is called as the longitudinal magnetization. So longitudinal magnetization is simply the movement of the proton in parallel or the anti-parallel to the external magnetic field, and net vector comes to in the parallel z axis. This is called as longitudinal magnetization. Now, upon this longitudinal magnetization, we will put some extra energy in the form of the RA pulse. Then this proton of the body will get some extra energy. This extra energy will force this proton to go to some another direction. So start to precision in the anti-parallel fashion. So net magnetic field will be somewhat away from the normal longitudinal magnetic field. So imbalance result in the tilting of the magnetization in the transverse xy plane. This is the called as transverse magnetization. First is what is RF frequency. RF frequency is the magnetic field we are giving to the patient. Another to that, the longitudinal magnetic field. If the longitude RF frequency and the precision frequency of proton is same, then only there will happen the exchange of energy in between the proton and RF frequency. This mechanism is called as resonance. So what is the resonance? The energy of the RF frequency or the frequency of the RF pulse and the proton precision frequency should be similar, so that only there will be exchange of energy in between the RF pulse and proton will happen, and this is called as resonance. Now, we will explain this by one diagram. If this man is walking on the street, normally on the plain street, if this man gets some extra energy, then suddenly this man will start to climb on the mountain. This extra energy is called as the RF frequency, which is giving in the form of the resonance. So, as soon as this man is getting some extra energy, it will get excited and wants to climb the mountain. But we will, as soon as he start to climb the mountain, we will switch off the RF frequency. Then this person again will start to walk on the normal playground. So what we did just right, just by giving the RF pulse and switching off the RF pulse, ultimately this person was in the normal plain road, or we can call it is a longitudinal axis. This is also longitudinal axis for the short period of time. As soon as we give this person some extra energy, this person start to climb on the mountain or in the transverse axis. So longitudinal axis, we give the RF pulse, this person start to climb the transverse axis, we switch off the RF pulse, then person start to walk on the road. In between the road and road, we have given some energy, and this person will release this energy in the form of the MRI signal. So here in there is this diagram, we can understand that this is our longitudinal field, this is our transverse field, which is perpendicular to our longitudinal magnetization. So as soon as we will give RF frequency, the proton will start to precise in the direction of the transverse axis, and as soon as we will switch off this RF frequency, this proton will try to go back to in their natural state called as the longitudinal magnetization, and the amount of energy which will release, we will receive it in the form of the MRI signal. So person will move in the longitudinal, then in the transverse, then back into the longitudinal magnetization. So here we can see that this person is getting the low energy, so obviously he is trying to cop up low energy in form of the walking in the normal ground. As soon as this person is getting the full energy, it start to climb on the mountain or in the transverse magnetization. So this energy it is getting in the form of the RF frequency pulse, and when we will switch off this RF frequency pulse, again the battery will get discharged and person start to walk on the road or in the longitudinal magnetization. So journey of the person from the longitudinal magnetization to the transverse magnetization back to the longitudinal magnetization will release some energy, and we will receive this energy in the form of the MRI signal, and we will transform this MRI signal into the MR image on the computer with the help of Fourier techniques. Now the question that we have received signal from the body, but how our computer will understand that this signal is coming from the which part of the body? Like we have a handsome man over here, so if we want to localize the ear of this person, so we have to divide this slice, we have to give some signal precise to this ear. So we have localization of the signal topic here. In the localization of signal, we will give three extra magnetic field which will be the perpendicular to each other. First will be the gradient. So localization of signal will be three more magnetic field superimposed on the main magnetic field along the x, y and z axis. These magnetic field have the different strength in the varying location called as gradient field or the gradient, called as gradient field or gradient. We will understand it. This is very simple topic. Okay, just imagine that you want to scan the abdominal part of this patient. So we have to make some fixed amount of slice that we have to imagine this patient. For that, we will make one gradient, or we will make a gradient of the MRI machine. So if this part is 1.4 Tesla, 1.45, 1.5, 1.5, as and as we will move toward the head end of the patient, we will try to increase the magnetic effect of the machine. This is called as the slice gradient. With the help of the slice gradient, now we will decide that we want one slice in between 1.6 Tesla and 1.65 Tesla. So this will give us one slice. So we want the image in the slice. So first our gradient is the slice selection gradient, or the gradient in which we will put the gradient in the longitudinal or the z-axis of the person in the form of the different Tesla of the MRI. So we will select one particular gap or a bandwidth and we will decide here we want the imaging. In next, if okay, imagine this is the slice from this particular portion of the body. Now we want to focus on the kidney, or we want that kidney should look somewhat different from the rest of the body. So we have to localize this kidney. For this we have to give two more kind of magnetic field. First one is called as phase coding and second is called frequency encoding. This is very simple. First, from this end to this end we want to focus, okay, imaging that we want to focus on this molecule of the body. This molecule of the body, we have to reach up to this molecule with the help of two more gradient. First is frequency. In this gradient, we will try to increase the frequency of the patient or this particular slice from right to left. Okay, imagine this whole row is giving the frequency of 60, this 70, 80, 90 and 100. Means all the molecule in all the protons in this line will resonance with the 60 hertz frequency. This line will resonate with 70, this 80, 90 and 100. Now we will give the phase encoding gradient in this axis or y axis. This is our x axis. So in y-axis, we will give the phase encoding in which we will decide the phase of the molecule in which they will resonate or show the frequency. Like here at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock and ultimately 5 o'clock. So if we have to localize this particular proton, then we will give the signal that we want to imagine one proton who is resonating at the frequency of 80 and at the 22.5, or in our layman term we can say that at a 2 o'clock position. So this is our frequency encoding, this is our phase encoding and this is our slice encoding. So slice encoding we are giving at the z axis and frequency at the x axis and phase encoding at the z axis. Here one more example is here. If we want to localize this particular proton then or the particular part of the slice, then we have to first give the frequency encoding. So imagine this is at the 60, 70, 80, 80 hertz and this is at the 1 o'clock, 2 o'clock, 3 o'clock, 4, 5, 6. Then we will imagine that 1 o'clock at this particular frequency, then we will come to our answer of the particular localization. So three gradient are there. First one is slice selection gradient which is applying at the z axis. Then we have the phase encoding gradient which will apply at the x axis. Then you have the frequency encoding gradient which will be applied at the y axis. So here also this is the diagram for the made easy by the Govinda. First one we will at the z axis we will put this gradient from head to toe so that we will get the particular slice, and then at the y axis frequency encoding and the phase coding at the x axis, then we will reach up to the particular target or the slice of our interest. So this is all about the basic in the MRI physics. In next class we will further discuss about the MRI physics. Thank you so much for watching this video. I am Dr. Rohit Solanki. Kindly like and subscribe my YouTube channel.